My name is Alexa Frigette, and I did my project on the immigrant foreign-born in an EU member country versus a non-EU member country. First, for the project, we were asked to evaluate and compare location quotients. The immigrant foreign-born population EU member country was my first choice that I decided to study, and it's the population of individuals who are immigrants that are foreign-born but are from another EU member country. So it's most likely going to be an immigrant within Europe, because most countries within Europe are part of the European Union. The other choice I decided was immigrant foreign-born in a non-EU member country. In the population of individuals who are immigrants that are foreign-born and from a country that is not an EU member country, which means it's most likely an immigrant that is not from Europe. The location quotient is used to describe the relative concentration of something in one section, European country, of a larger area, Europe. My hypothesis for my data was that a particular country that has a larger amount of immigrants that are foreign-born in an EU member country, they will have a large amount of immigrants that are foreign-born from a non-EU member country. I thought that this would be because that particular country is a more desirable place to live and that there are more job opportunities within that country. I suspected that, obviously with the data, that my two different location quotients would have a positive correlation between these two, and it's supposed to be a linear relationship. The data that I found was I used Eurostat to find the data tables, and the information it said was from 2012. The data was presented in a table with numbers of thousands of individuals and also percentages, but I chose to ignore the percentages and just use the raw data. The data table included total number of foreign-born immigrants, total number of immigrants in Europe, number of foreign-born immigrants from an EU member country, and the number of foreign-born immigrants from a non-EU member country. The methods I used were I used the location quotient method, and it uses the country-level quantitative data with population as the norm. And I studied only the 32 countries in Europe, because I couldn't find, that was all the data provided were those 32 countries. The country ratio for each variable and each country was what I found first, and it was thousands of foreign-born in an EU member country divided by the country population. Then I did the Europe ratio for each variable, and it was the thousands of immigrants in Europe divided by the total population of Europe. And then I divided each country ratio by the nation ratio for each, or the national ratio for each country and each variable. This is an example of part of my spreadsheet. The country location quotients mapped individually by a variable. I made my maps personally by hand using the outline map of Europe provided on Blackboard, and I grouped my values into 4 categories, so it placed 8 countries into each group. For my symbology, I used 4 different colors. So for my results, immigrants of the foreign-born in an EU member country showed that the ratio for Europe is 0.002347, or about 23 immigrants per 10,000 people. The highest LQs are in Luxembourg, Cyprus, Switzerland, and Liechtenstein. Luxembourg has an LQ of 10.17, which showed that for 13,600 immigrants foreign-born in an EU member country out of the 570,000 people. So for every one of these immigrants in Europe, the foreign-born in an EU member country, Luxembourg has about 10 of those individuals. Cyprus had an LQ of about 4.766. Switzerland had an LQ of about 4.314. Liechtenstein had an LQ of about 3.454. The countries with the lowest LQs were Portugal, Estonia, Romania, and Croatia. The data ranged for this was a little bit more. It went from 10.17 to 0.0455, and for the immigrants that are foreign-born in a non-EU member country, the LQs are much closer together. I'm sorry that this is a little bit difficult to read. The scanner was having some difficulties with the documents. As you can see, the countries with the highest immigrants foreign-born in an EU member country are highlighted in red, and then next in orange, but it looks a little yellow in the picture, then green, and then the ones with the lowest were depicted in blue. Immigrants foreign-born in a non-EU member country, the ratio for Europe is 0.003133, or about 31 immigrants per 10,000 people. The highest LQs are again in Luxembourg, Liechtenstein, Cyprus, and Malta. Luxembourg has an LQ of 2.968, so for every one of these immigrants in Europe, Luxembourg has almost 3. Liechtenstein has an LQ of 2.588, Cyprus an LQ of 2.405, Malta an LQ of 2.328. The countries with the lowest LQs were Slovakia, Portugal, Bulgaria, and Latvia. As you can see, like I described earlier, the countries that have the difference between the LQs is much closer together for the immigrants foreign-born in a non-EU member country. When I scanned this document, it cut off the portion where it was depicting the blue, so I said that the blue value should represent 0.474220. Again, I couldn't scan them incorrectly, so this was as good as I could get it. Again, the highest are depicted in red, and then next orange, green, and then blue. I created a scatter plot to show the correlation between the immigrants foreign-born in a non-EU member country versus an EU member country. And as you can see, the correlation is very strong. It's almost 1 in 7, or 0.77, and as you can see, it's also a positive correlation between the two. My conclusion is that there is a strong positive correlation between the two variables, so there appears to be a relationship between the two. The countries whose LQs are highest for both categories are countries that are all quite wealthy compared to others. So to me, this indicated that they were all probably very desirable countries to immigrate to, which is why their LQs were higher. So since they're from wealthier countries, they're more likely to inspire people to go there. They might also have more job opportunities, as described in the beginning with my hypothesis. Thank you for listening to my presentation.